Okay, just a recap of our trig functions for right triangles. So it's SOHCAHTOA is how you can remember the ratios. So the sine of theta, some angle, is equal to the opposite over hypotenuse. The cosine of theta, some angle measurement, is equal to the side length adjacent over the side length hypotenuse. And then tangent theta, so the tangent of some angle of the right triangle is equal to the side length that's opposite over the side length that's adjacent to the reference angle. And again, you're going to make sure you use your TI calculator. So first of all, let's see what we have. Our reference angle is 54, and our components, so this is going to be the opposite. This is always our hypotenuse, the length that is opposite of your right angle. And then this is adjacent. This line segment is adjacent to our reference. So we're going to be using adjacent and hypotenuse. So that is going to be the trig function is cosine. So the cosine of 54 degrees is equal to A, which is 15, over our hypotenuse, which is x. So again, have your handy dandy calculator ready. We're going to cross multiply these so you can just, assume that this is a 1 in the denominator. So we're going to get 15 is equal to x times the cosine of 54. So again, in my calculator, well, before we pick the calculator up, we have to isolate x. So x is going to be equal to 15 divided by the cosine of 54. So I'm going to use n over d. And we're going to have 15, and then in the denominator, cosine of 54. And I get about 25.5. So x, the length of the hypotenuse, is about, and we'll just round to the 10th. Okay. Number 2, our reference angle is 31. So again, this is going to be your opposite. This is the adjacent angle. It's adjacent, it's next to. And yeah, I know 13 is also adjacent, but it takes on the hypotenuse. It's directly across from your right angle. So the trig function that deals with, we need to use the adjacent and we need to use the hypotenuse. So again, that's going to be cosine. So the cosine of 31 degrees is equal to your adjacent length divided by your hypotenuse length. We're going to cross multiply. So x is already isolated. So in our calculator, 13, and then cosine 31, and I get about 11.1. So the adjacent side is about 11.1. Number 3, x is our hypotenuse. Oh, here's our reference angle. So this time we do know the opposite length. We don't know the adjacent, nothing's given. So we're going to be we're trying to find the hypotenuse. So we need to use the opposite in the hypotenuse. So that's sine. So the sine of 41 degrees is equal to opposite over hypotenuse. We'll cross multiply. And we'll isolate x before we calculate anything. So I'm using the n over d feature, 11, and then the denominator is sine of 41 degrees. And I get 16.7667. So I'm going to say about 16 point, we'll round up to 8. Number 4, our reference angle is 71. So we know the hypotenuse, we don't know the opposite, and then we're looking for the adjacent. So we're going to be using adjacent and hypotenuse, so that is cosine. So the cosine of 71 is equal to the adjacent length divided by the hypotenuse. Cross multiply, so x times this 1, and then we have 11 times the cosine of 71. X is isolated again already, so just in your calculator, 11 times cosine 71. That gives us about 3.58, so I'm going to say about 3.6. Okay, so our reference angle number 5 is 59. This is opposite, this is adjacent, and this is the hypotenuse. So again, we're using adjacent and hypotenuse, so that's cosine. So the cosine of 59 degrees is equivalent to adjacent over hypotenuse. Cross multiply. And in our calculator, we get about 6.695, so that's going to be about 6.7. Okay, number 6, our reference angle is 40 degrees. So 17 is the opposite. We don't know anything about the adjacent, and x is our hypotenuse. So we're going to use opposite over hypotenuse. So that is the trig function sine. So the sine of 40 degrees is equal to the opposite length divided by the hypotenuse length. We're going to cross multiply. We get 17 is equal to x times the sine of 40. We need to isolate x. So I'm going to use my n over d feature, my calculator, 17 over sine of 40. I get about 26.447. I'll just say 26.4 since we're rounding to the 10th. Again, remember we're finding the measurements of a missing side length. Now, once we found this x value, so this is 26.4, we could find the adjacent. We could use a trig function. We could use Pythagorean theorem. So now if I wanted to find the adjacent, I could use tangent, which is opposite over adjacent. And if there's not one like that on this handout, I will show that. So when we know two side lengths, we have several options. We could use tangent. Like I said, the tangent of 40 is equal to 17 over A. We could use the adjacent hypotenuse. Okay, so that is cosine. So we could use the cosine of 40, or we could use Pythagorean theorem where we have a squared plus 17 squared is equal to 26.4 squared. So you have several options when you know two side lengths. Okay, our reference angle is 36. So I think we're going to use tangent here. We don't know anything. We're not looking for the hypotenuse. We don't know the length, so we're not going to include the hypotenuse on this one. So the opposite is 13. My adjacent is x. And so this is tangent. So the trig function, the tangent of 36 degrees is equal to 13 over the adjacent segment. So we're going to still cross multiply. So 13 times 1 is equal to x times tangent of 36. Divide each side by tangent. So in my calculator, use the n over d, and we're going to do 13 over tangent 36. I get about 17.89, so 17.9. So this measure is about 17.9. And again, if we wanted to find the hypotenuse, we could use Pythagorean theorem. We could use, if we were using the trig functions, this would be the hypotenuse, and we could use the opposite. So that would be opposite over hypotenuse is sine. We could use cosine, which is adjacent over the hypotenuse. So again, you have several choices there. Number 8, our reference angle is 30 degrees. This is a 30, 60, 90. So you could go back to the pattern formulas, but since we're working with trig functions, let's just keep doing what we're doing. So here, the 15 is your opposite side length. X is your adjacent, and we're not trying to find the hypotenuse, so we're not using that. We don't know any value. So opposite over adjacent, like a number 7, is the trig function, the tangent. Okay, so the tangent of 30 degrees is equal to opposite over adjacent. We're going to cross multiply. We're going to divide each side to get x by itself. And 15 over tangent 30 is going to give us 15 radical 3, but since we are working with rounding to the nearest tenth, it's 25.98. So that's going to round us actually to 26, so about 26. So x is about 26. Our reference angle is 18. So from this perspective, 15 is your opposite side. X is your adjacent, and this is your hypotenuse, but we're not using hypotenuse at all. So we're going to use opposite over adjacent. So that is tangent. So the tangent of 18 degrees is equal to 15 over x. Cross multiply. Notice that the x is your coefficient of tangent, so it comes out front. We're going to divide each side to isolate x. And 15 over tangent 18. 46.165, so 46.2. Number 10, so our reference angle is this. This is the 75. So 11 is going to be the opposite, and x is going to be adjacent. So we're not doing anything with the hypotenuse, so that deals with tangent. So the tangent of 75 degrees is equal to the opposite over the adjacent. Cross multiply. And we have 11 divided by tangent 75. And again, try that one more time. And I get about, so at first I got the radical negative 11 squared root of 3 plus 22. So then I had to toggle, and I get about 2.9. Number 11, this is my reference angle. I have my hypotenuse, I have my adjacent. Here's my opposite. So I'm dealing with adjacent and hypotenuse. So that is cosine. So the cosine of 22 degrees is equal to the adjacent over your hypotenuse. Cross multiply. and x is isolated. So right in my calculator, 16 times the cosine of 22, and I get about 14.8. Number 12, my reference angle is 71. This is my opposite. This is my adjacent. This is my hypotenuse. So I'm using opposite over adjacent, so that is tangent. So the tangent of 71 degrees is equal to the opposite over the adjacent. Cross multiply. Again, put your coefficient out front. Divide each side. And we have 11 again over tangent 71. And I get 3.787, so 3.8 about.